Okay. Um, okay. The last thing we're going to do this week is electrical power. Okay. Now, let's get something clear. Okay. So energy, okay, is measured in joules. Okay. It's measured in joules. Okay. Now, the unit is joule. Okay. So power, okay, as we discussed before, the power will be the energy divided by time. Okay. So the idea is, say if I transferred, okay, 10 joules of energy in 2 seconds, the power will be 10 divided by 2, and the unit will be in joules, okay, per second. However, the scientists found joules per second is, well, it's somehow hard to say, okay, all because we use it often. So joules per second is transferred to watts. Okay, so if if I'm talking about, say, my computer is 120 watts, okay, watts, sorry, it's 20, sorry, if my computer is 120 watts, it means my computer delivers 120 joules of energy every second. Okay, now if you look at, um, now if you look at your household electricity bill, okay, now you find the word, the unit, kilowatts hour. Now, what does this mean? Okay, this is a unit only used in, um, well, in domestic power companies. Okay, so kilowatts hour means the energy. Okay, don't, yeah, I know it's confusing. Okay, the energy, say 10 kilowatts, say 1 kilowatts hour. Now, it's the energy. Okay, I'm operating something, some component at 1,000 watts, okay, in an hour. Okay, let me put it down. Energy needed to operate, okay, 1,000 watts in an hour. Okay, so basically we can calculate it into joules. It's a measurement of energy. Okay, so 1 kilowatts hour equals to 1,000 watts, which is joules per second, times the number of seconds in an hour, which is 60 times 60. Okay, so if you put it in your calculator, it will be uh, so will be this much. Okay, 360,000 joules. Okay, now, but what we need to know today from Ohm's law is all the equations. Okay, now for now, just copy them down. Okay, the power is VI, okay, voltage times the current, and we learned that before. However, Ohm told me, okay, he told me that voltage is also IR, okay, current times resistance. So if I put it in, okay, if I substitute voltage into IR in the power equation, I have I square R. It also works. Okay, the other way around, okay, current is V divided by R. Okay. If I substitute this into that equation again, okay, now power can be also calculated in V squared divided by R. Okay. Also, previously we learned the voltage times the charge divided by the time. Okay, so this is the equation for you to find power, so write it down in your notes. Okay. Now, let me do a brief example. If I have a circuit, okay, the resistor is 100 ohm. Okay, the battery gives 6 volt. Okay. Now I can calculate how many energy does this resistor use. Okay. So if I do that, okay, I have R, I have V. Okay, so I use this equation here, P equals to V squared divided by R. Okay, the power is 100. Sorry. 6 squared divided by 100 is going to be 0.36 watts or 0.36 joules per second. Okay, now, yeah, just for your information again, okay, 1 joule of energy is the energy you need to push, basically to lift an apple from the ground to 1 meter above this 1 joule of energy. Okay, that's what it means.